This will be a little different. I wish I could figure out how to get spacecraft into NFTs. It's been a rough kind of year or so for us, all of us here. You're sitting so spaced out, masked, socially distanced. It's been a rough time. And that rough time has had mostly downs, but there have been some ups in the last year and a half. And one of the great ups, at least for me, was this.
Propulsion, go. EDLC, go.
We have team Perseverance ready to execute entry descent landing on our own.
Parachute has deployed and we are seeing significant deceleration. The nacelle has separated. Sky maneuver has started. We're 20 meters off the target.
Draco Delta, nominal.
Touchdown confirmed. Perseverance safely on the surface of Mars. Ready to execute the landing pathway.
So, we landed a rover on the surface of Mars in the middle of a global pandemic. We launched her from Cape Kennedy at the height of the summer surge. That rover's name is Perseverance. Kind of a phenomenal name for the time that we are in. We named her before the pandemic hit. In fact, I was part of a group of people who looked at the names. It was a contest amongst school children around the world with essays and a name, and all those were sort of poured over, and eventually we came with this Perseverance. And I actually didn't like Perseverance as a name. I said to myself, this was in late February of 2020, I said, Perseverance requires us to be struggling against something. Doodle-doodle-dood. I want to talk a bit about Perseverance. I want to talk about getting onto the surface of Mars in the middle of a pandemic. I want to talk about her little friend that she took with her, the helicopter Ingenuity. And I want to offer some lessons that I think I learned from my team and the experience that we might all use as we look to go forward in our world, as we hopefully pivot out of this hard time and into sometimes better. But first, let's talk about Mars. For eons, Mars has captivated our attention. Before we could had aids to our vision, we looked up at the night sky and saw a light a little brighter, a little redder than the other lights in the celestial sphere. When we got early aids to our vision, although they were sort of crude, the first telescopes, we looked up and we saw life. We saw roadways and canals. We saw civilization. And then we realized that those are actually just natural features of the surface of Mars. But we never lost the idea that maybe Mars was alive. Because it's kind of a profound question, right? Are we alone in our universe? Are we alone in our solar system? Could one of our nearest neighbors harbor life? NASA has been trying to peel back the layers of the onion on that question for decades. And here is a family portrait of the rovers we put on the surface of Mars to try and understand the history and potential habitability of Mars. Starting in '97 with a tiny little Sojourner rover, size of a microwave oven, important because we were able to put her on the surface of Mars for less than 1/10 of what we'd paid to make it to Mars successfully in the '70s with the Viking landers. Because of that, we said we're going to go back. We're going to go back to Mars again and again and again. In fact, the NASA administrator vowed, pounding the table, to return to Mars every opportunity we have. The way that the Earth and Mars go around the sun, you can only make it to Mars every 26 months. There's a little dip in the energy required when the planets are in the right spot. But we said every 26 months we're going to go to Mars. We're going to be on the surface of Mars every 26 months, but you can see there's more than 26 months between '97 and '04. And that's because we failed. We had some failures. We were playing a limbo game. How low can you go in terms of cost, in terms of number of people working on the missions? And it ends up being There's a certain ante of human brain calories you need to spend to be successful. If you don't, you can make a smoking hole on the surface of Mars, but you can't successfully make it to this surface. But we rallied, and in 2004, we put twin rovers, Spirit and Opportunity, on the surface of Mars. They were very important for these questions of life because they taught us that liquid water had been on the surface of Mars. And we know from here on Earth that where there's liquid water, there's life. But they couldn't tell us some important things about the water. Was it salty, sweet, acidic, basic? In short, was that early wet Mars habitable for life? Well, in come the nuclear-powered mega rovers. Curiosity in 2012. Chock full of all the science equipment necessary to answer this question about the early wet habitability of Mars. Could early wet Mars have been habitable for life? She gathered in situ data, sent it down to the Earth, and scientists here on Earth concluded the answer to the question she'd been sent to ask, and the answer is yes. Early wet Mars. 3 billion years ago, when life was just getting a start here on Earth, the conditions to support life were ripe on the planet Mars. Now, we don't know whether life started there, could have started there. It could have in terms of an environmental. Did it? We don't know. We actually know that the planets, both of them, were communicating with one another, a very low bandwidth protocol, but impacts in the orbital, early solar system orbital debris, late heavy bombardment, was sending material from Mars to Earth and from Earth to Mars. So life could have started on Earth and shot to Mars and flurried on Mars and still be there present. Or life could have started on Mars and come to Earth and we're actually all Martians. It's actually a thing. Could really be. So, that's pretty cool. Because it was so cool, we followed Curiosity on with her twin, a little tiny bit bigger, a little bit brawnier, Perseverance, in 2021. She's got a sampling system, a system that can drill into the rocky material of Mars, take very special intact core samples of the Martian rocky surface, and seal them in hermetically sealed, agonizingly sterile vessels for return to Earth. But these mega rovers are really difficult to land, to get them safely onto the surface of Mars. In fact, we had to come up with an entire new way to land. First Curiosity and then Perseverance. This is a simulation of one of over millions of simulations that we would do before we'd ever push the launch button. Here we're landing the rovers on the surface of Mars, so slippery it can't rove, and yet we successfully land by lowering them below their jet backpack, the descent stage, the propulsion system, in a maneuver we called the sky crane maneuver. In 2012, I led the team that developed that technique, and in 2021, I led the entire rover for Perseverance to get her safely to the surface. I used to get so much criticism when we talk about the sky crane maneuver. I used to come up with this little pithy statement I would make before I would ever talk about the sky crane. It goes like this: great works and great folly may be indistinguishable at the outset. Now, I love that statement because it's simultaneously true and meaningless. Those are some of the funnest things to say, right? I mean, the truth of it is obvious. If something's very, very different, a good example is NFTs, non-fungible token, how does this really, right? When something's very, very, very different, you don't have a term of reference with which to understand it, and it appears crazy. It's just like a cognitive dissonance. Now, the truth of the meaninglessness of this statement is, of course, that crazy also looks crazy. So just because you say something that's outlandish doesn't mean, that you're not absolutely whack. But I promise you, if you ever say that phrase, great works and great folly, may be indeterminate at the outcome, people will then take whatever you say later like, whoa, that's intense. At any rate, we all had to come together and ask that question of ourselves on landing nights. First in 2012, it was a success. Second in 2021, 2021, on February 18th, it worked. Here is us wiggling Percy's toes. We landed the rover on our feet, on her wheels, 6 of them, and the first thing we did was start to move all the actuators, light up all the copper, make sure that we actually got the whole spacecraft intact to the surface of Mars. Then we took images of where we were. I love this one. This is one of the first images we took. You can see wheel tracks from us having spun in place, and then you can see that bright orange image up there is where our rocket plumes have scoured away dark overlying material and leaving the fresh iron oxide-rich dust that gives Mars its signature color. Then we trained our cameras on the reason for the season. We came to a place called the Jezero crater, pronounced correctly, Jezero crater. It's an old impact crater that was, when Mars was wet, a lake. And there was an inflow channel that left a big delta, a fan structure like we see New Orleans, Alexandria. That kind of deltaic deposits are great for preserving signs of ancient life here on Earth. And so we went to Jezero to look at that, which is one of the remnants of that deltaic fan deposit. There's others. That indistinguishable blob may have signs of ancient microbial life that started 3.5 billion years ago on Mars. Or maybe not. We don't know. But we came here to ask the question, to see what we could learn about the surface of Mars. And we brought a friend. It looks like a photograph, but it's actually a movie. This is Ingenuity spinning in place as she hovers on her second flight above the surface of Mars. She's now taken 13 and counting, and continues to amaze us as to her success. So here's that beautiful fan-like delta seen from orbit. This is a digital elevation map constructed by overflight data from XRISM and HiRISE, all on the Mars Reconnaissance Orbiter. It's been assembled to give you a height-accurate perspective as if you were flying about 30,000 feet in the air. And you can see a little star down here where I've placed the approximate location that Percy and Ingenuity are as they scurry about the surface, doing the scientist's bidding, asking the questions about what's going on with the history of Mars. I love them. 2 great names, 2 great human attributes: perseverance, ingenuity. So I want to share some lessons that we learned as we got them to the surface of Mars in the middle of this yogurt that we've all been sitting in for the last 2 years almost. First, amazingly, we human beings are incredibly capable of adjusting to disruption. It was a fantastic gift, in some sense, for the tech industry, right? We all of a sudden went virtual. We never, ever, ever could have gone virtual. If you'd asked the staff at the Jet Propulsion Laboratory 2 years ago if you could operate a spacecraft from home, the answer would have been categorically not. In fact, a big, long list of ironclad reasons why it could never happen would have been given to you. But it just takes a bit of perseverance. Couldn't help mention it. But seriously, to stomach through the disappointment, to keep your eye on the focus, and, you know, I would normally be shoulder to shoulder. This is operations, physical operations, for a test that we really need to be physically present. There'll usually be 60 of us. There were 6 of us, masked, can barely hear each other because you're so spread out. This is early days. We were very, very worried. Nobody was vaccinated. Operating from home, impossible, except we did it. Changes to our personal lives, right? This is family, bi-weekly family trips to Dodger Stadium for family COVID tests. My son and my daughter both attended school in the living room, which is challenging for a 3rd grader. But these are things we all did. And adapted to. To meet the challenge, some sectors, some certainly in tech, some businesses, some groups really actually bloomed during the pandemic because they were able to see the opportunities that the disruption created. They were able to see the new world that we were all in for what it really was and look for solutions, ingenious, creative solutions. That beautiful helicopter, Ingenuity, almost didn't make it to the surface of Mars. We needed to come up with an ingenious solution to close her design process. Independent team working fast to try and get her on board. This is a great image. This is made on Earth, by the way. She has a hazard detection camera that she shoots little black and white images looking for rocks where it's safe for her to land. She autonomously finds where she can land and lands. And then we took a set of those images that we downloaded here on Earth and stuck them together into this GIF. She almost didn't make it because our original plans were to strap her between the wheels on the side of the rover. So this is our rover as we're putting it together in SAF, the Spacecraft Assembly Facility at the Jet Propulsion Laboratory where I work. And we were planned to put Perseverance between the two wheels on the side of the rover. That was going to require her to fold her rotors in half and tighten the vehicle into a tiny little package. We'd have to deploy this thing like a lunchbox. It had to have batteries on it. We would drive away from it, and then battery powered, it would go through this unfurling effort. Now, the lean, mean team that was in the middle of developing the helicopter, using also some open source software, swore they could do it, but we were worried they might not be able to make it. So we made a late call to move her from the side of the vehicle on to the belly. That belly was going to be dangerous for her and dangerous for us. You might be able to see her there. Let me give you a better picture. I'm going to flip her over. Now you're looking at the belly of the vehicle, and now you can see Perseverance a little bit more clearly. The dual rotors, beautiful carbon fiber, super lightweight. We had to protect her against the landing event. The landing event, when you're landing with rockets anywhere, it's a very dusty, dirty affair. And so we had to protect her against debris on impact. We had to get rid of that debris shield, but we did. In fact, here's a great image we took just after dropping the debris shield on the surface of Mars prior to deploying Ingenuity from the bottom. And here is my favorite image thus far from the project is this one. The first ever image of a spacecraft on the surface of Mars from another spacecraft on the surface of Mars. This time flying, right? That's pretty cool. So, some notes on leadership or community, because these acts can be done by leaders of teams, but they can also be done by team members or any member of a community, right? It's really something that we can give to each other. First and foremost, the importance of sorting fact from opinion. That gets harder and harder the closer the facts get to the noise floor, right? When you're really trying to unpuzzle something that is statistically in the noise, it is a challenge. It can be important, as for instance our epidemiological public health issues have been over the last 2 years, but also very difficult. In my world, I've got different siloed individuals, people who look at a piece of the elephant, as it were. You know, I've got my mechanical subsystem, my telecommunication subsystem, my guidance subsystem, et cetera. And each of them see the challenge before us together as a team through different pieces of it. And it's my responsibility as a leader, but a responsibility that any member of the team can have to look outside your own stovepipe, look across at your other fellows' perspectives, to see compromise and to find a balanced perspective for which the team and the collaborative effort can move forward. Humans, us teams, we only succeed as teams. We're weird. As individuals, we might have a great idea, but if we really want to succeed, we band together in groups we call teams. And the success of the team is sort of the success of the product that the team is is working on. They're directly proportional. You can't pull one from the other. You can't have a miserable, unhappy, non-collaborative team and get consistently great results. So how do you boost that collaboration? How do you have everybody comfortable to bring all of themselves into the work? Well, I use a technique based on selfishness, but it works. It is to find something to like, nay, love in everybody I work with. Now, I go to work when I'm going physically to work a lot. And virtually, I'm in contact with my team almost all the time. So I have a choice. I can look for something to be annoyed with my colleagues, and there's something always there. The way the guy puts his feet up on the table or smacks his gum, what the hell, right? Or I can look for something to love, something to connect with, something to appreciate. Well, I do the latter because I want to have a good time at work. And it works. I have a blast at work. But a weird side effect happens. They notice. They like it. They try it out on me. They try it out on each other, and pretty soon we're in a supercharged collaborative love fest. We're having a good time at work, and we're creating an environment where everybody feels comfortable to bring the most of themselves to the effort that we're working on. And then finally, something I've noticed from this virtual world that I've been in more than I ever was before. To really get the most out of a team, you've got to make space in the room, physical room or virtual room, for the team members to be able to bring their ideas out. And for me, especially in the virtual environment, I try and do that by talking less and listening more. I find that I learn a lot more by listening rather than by talking. So, what about the future? You know, we are going to come out of this. We are going to go make something new happen. What's it going to look like? I certainly prefer to think of the future as an opportunity for better success. I'm a positivist in that regard. And, you know, as long as we have the grit to deal with the disappointments, there will be. Spikes will happen. Changes in protocols will occur. Variants will spring up. But we'll find greater success. And one of the tools that we'll use to get there is our native human curiosity. Also the name of a nuclear-powered mega rover, right? We're on a streak. Perseverance, curiosity, ingenuity, these are, and this is not by design, I promise you, but it ends up being the kids of the world are good at grabbing essential human attributes that have meant our success as a species and given great names to spacecraft on Mars. Curiosity, I know a bit about curiosity because curiosity changed my life. This image is taken from San Francisco, from the Marin headlands above the Golden Gate Bridge on the other side, the north side of San Francisco Bay. It's apropos because it's taken about a mile from the house I grew up in Sausalito. It's also apropos because of that star constellation sitting in the upper left of the image. You may not be able to recognize it. It's the constellation of Orion. I was a very poor student, terrible student, in fact, barely graduated high school. I graduated geometry class the second time I took it with a grade of an F+, because Mrs. Hunter really did not want to see me in the class a third time. So, after high school, I was playing rock and roll around the San Francisco Bay Area, not a particularly gifted musician, sort of hoping that lightning would strike and make me the next Elvis Costello, which would have been totally cool, but it wasn't going to happen. And one night, returning home from playing a show, I noticed that the stars were in a different place in the night sky than they had been when I went out to the show. I'd gone out and loaded in, they were over the east. I was coming home, they were over the west. And I was like, oh my God, the stars are moving. Clearly, I'd missed that whole Earth spinning on its axis thing they teach you in school. My mind was blown, and I allowed myself to follow my curiosity about the apparent motion of the stars in the night sky down to local community college, technical college is sometimes called, 2-year institution, and take an astronomy course. It had a prerequisite of a physics course that I could take at the same time. But the title of the physics course said conceptual physics, physics without math. All right, I'll give it a try. Well, the guy who taught that course, a guy named Stephen Prada, took that spark of curiosity that I'd experienced about the apparent motion of the stars in the night sky and turned it into a fire of exploration that burned across my life and changed the course of my life and maybe even changed the way we land spacecraft on the surface of Mars. If Adam of yesteryear were been told of what Adam of today's job is, his head would explode. But we never really know where our curiosity might be able to take us. It's a very powerful tool. When we explore, right, curiosity is the spark, exploration is the fire that burns from it, we're asking questions about ourselves as human beings. Who are we? How grand are we? We're looking for the edge of us. We're staring into the unknown of who we might be. I think Neil Armstrong appreciated that with the words he would choose to say when he'd first stepped foot on the moon. One small step for man, one giant leap for mankind. He was suggesting that he was carrying all of us with him, and that as he became more by the juxtaposition of that tiny footprint against the vast backdrop of space, we all became more. When we explore, we're asking questions of humanity. What are we capable of? Well, I've been thinking about this. Only since landing Curiosity. Before landing Curiosity, I was a dumb engineer, unbelievably lucky enough to be leading the most talented set of aerospace engineers to be assembled in the last 40 years. But after we landed, and I watched people freak out, I started to wonder why we do this. And I've concluded that curiosity, it's in all of us. It's in our genes. That's kind of our bag, baby, right? We are born through hips too narrow to pass a fully human body, brain. We come here basically unprogrammed. We don't know to go south in the winter or look for worms under the shade of the alder tree, right? We come with very few lines of code. Perhaps one of the most critically human is be curious. And we all are. Before any of you could speak, you knew the difference between a solid and a liquid. You knew something about mass, distance, and time, all constructed in your wordless mind through exploration, driven by your native human curiosity. Whether you identify as being curious or not, you are. Now, a weird thing happens as we get older. The model we start to build at day one, at time t0 plus, it gets pretty good. I couple that to a little internet connectivity and a smartphone, and I start to believe that I know exactly the temperature it's going to be in Raleigh, North Carolina, tomorrow morning at 10 a.m., to within a degree Fahrenheit. I start to really anticipate that I know what the future is going to be. 2020 was a great wake-up call for me in that regard. Boy, I had plans. None of them happened. Now, if we keep our minds curious, a little bit like a child's, connected to our natural native human curiosity, they stay agile, much more innovative, and subsequently more competitive. And if we can take that attitude and put it with the perseverance we'll need to knock through these lumps and trickles that we'll get as the future goes on, these challenges that will be arise as we stare into an uncertain future, we have the opportunity to author a better future for ourselves. So what's next for NASA? Where will NASA's Curiosity next take it? Well, Perseverance is part of a big, huge, epic adventure called Mars Sample Return. It's the biggest thing that NASA's ever taken on. It's actually an international collaboration between ESA and NASA. It takes 3 individual missions to bring samples back from Mars. The first of those, Perseverance, she's on the surface of Mars. She's already taken a couple of rocky core samples and an atmosphere sample. But there's follow-on missions. Sample retrieval lander and an Earth return orbiter launched by the European Space Agency. Those are due to go up in 2028 and return samples in the early 2030s. And I'm currently the chief engineer of the whole kit and caboodle. But Mars is not the only place to explore. Europa, ice moon of Jupiter, a thin ice crust protecting a liquid water ocean more than twice the volume of all the seas on Earth. Now, I'm just an engineer, I'm not a biologist, but I drink beer with biologists. And they tell me the number one place for them to find life existing today, their number one bet, is in the waters of Europa. So I hope to help NASA put a lander on the surface of that ice and look for what evidence might have upwelled from underneath. So now I look at that beautiful fan-like structure. It used to scare the bejesus out of me that we could land on it successfully, or intentionally not land on the bits that we didn't want to land on. But now I look at it and it fills me with sort of anticipation. What awaits us in that delta? What does the future hold for all of us, really, on the back end of this pandemic? How can we take lessons that we've learned in working together virtually and physically, skills we've developed, the grit and determination, the perseverance to overcome the hard times? How can we take that and turn that into authoring, writing for ourselves a brighter future? Well, I wish us all luck, and I'm pretty positive about it. Thank you very much for your attention.